So I'm going to be talking about another touch input technique, and it creates a new input space. This is just to acknowledge Corona, my co-author. As you can see, she recently graduated, but due to visa issues, she couldn't come to give the presentation herself, so you're stuck with me giving the presentation on her behalf. But you should know that she did all the hard work. So a common problem with touch input is that you need to issue these kinds of contextual commands. So imagine a simple photo application. You've got many different commands. You need to actually perform on these different thumbnails for photos. So you have to open them, select them, copy them, delete them, maybe even rotate them. You also ideally want to reposition them by dragging. So a touch can sometimes be interpreted as a beginning of a drag. And you also need to scroll these photos up and down if it's a large photo album. So combining all these kinds of commands into one direct manipulation interface requires distinguishing different kinds of touches. A common strategy is to use a long press. This is what's used in Android and iOS in many cases. So pressing and holding a particular thumbnail in this case activates a context menu, usually up in the top right. So this is slow in terms of time, and because the commands are located away from the object of interest, it's not as ideal as it could be. So a marking menu is another option. The challenge with a marking menu is to both preserve object dragging and these directional strokes. You still need to use that same kind of long press to distinguish between those two different commands. So these are both examples of something called touch overloading, and there's been quite a bit of work in this. I just showed you the long press, which is an example of using time as a way to do this touch overloading. Of course, you can use multiple fingers. You can just count the number of fingers to do different kinds of commands. There's been work at UIST and CHI and other venues looking at different other kinds of qualities of touch, and we just saw an example earlier in this session using pressure. And there's a group of work that's looking at basically standard types of touch, but looking at things that are unique or different in how those touches are activated. So bezel touches, a touch crossing from outside to inside the display, and fast but distant taps, which typically don't happen during normal touch input, can be used for this touch overloading purpose. And our work fits into these sort of this last class of techniques, so looking at standard touch input, but finding ways to overload by looking at sort of unique types of patterns of touch input. And the way we do this is leveraging two different ways that you can select targets. So we all know that you can tap on targets just by tapping on the target, but you can also cross through targets. So if it's a line or even a square, I can cross through it, and I can cross through it in two different directions to actually get two different commands even on that same target. What we do is we combine these two things together. So at the same time, I can tap on a target and cross a target that's nearby. So this becomes sort of a small little gesture, and if you think about it, this doesn't actually occur very often in normal touch input. So it's something that's unique in the touch input space. So we can combine these two things, and the really nice thing about it is at the same time, you indicate what object of interest you're interested in. You can also drag things without any overlap. So at the same time that you pin or press on the target and cross, it says, this is the target I'm interested in, the object I'm interested in, and here's the command that I want to orchestrate. And you can cross in different directions for different kinds of commands. In this case, rotating clockwise or counterclockwise. So a common question people ask, well, what do you do about objects on the edge? Well, we have this spring back technique. So I can drag an object from the edge, bring it into the middle, perform my pin and cross action, and then release it, and it springs back to where it was. And notice that it still preserved dragging. I could still continue and actually drag that object. I don't have to perform the pin and cross action. So this simple idea of combining static touches and nearby crossing actions creates actually a really large design space. So we had to pare down to just a couple different aspects of this for this project. So we're looking at pin and cross actions that are performed with a single hand, using one finger or two fingers, and I'll show some examples of two fingers in a moment, and crossing directions that are around the pinned finger. You can imagine crossing targets towards the pinned finger, but that actually tends to collide with pinch to zoom, for example. So here's some other examples of using, in this case, using a two-finger pin, so a way to extend crossing to either page up, page down, or skip to the bottom or top. Extending rotate, scale, transform by turning object snapping on and off in the middle of doing the transformation action. And even changing direct manipulation. So without lifting my finger, I can change from drawing sketches to lines to rectangles in this case. And I'll show some more demos about that a bit later. So before we actually designed these techniques, we ran a formative study to understand what kinds of crossing actions or what kinds of targets are most comfortable to use, and to also gather some kinematics and preferences for these same kind of targets. So we can use the kinematics to design some recognition heuristics, and performance and preference to decide good targets. So we tested 16 different targets arrayed around the pin target. So that diagram, you can imagine the pin target at the center circle. And we did this over multiple blocks. I don't talk about it in this talk, but it turns out people can actually learn this very quickly. We had a small learning effect for the first block, but afterwards people got the technique. We looked at 4 different task variations, so I'll explain what those are right now. So this is actually actual experiment video. We had 4 different tasks. The first task is the most straightforward one, so a single finger pinning and another finger crossing. We didn't give any particular instructions on what finger to use to pin or cross. So that's important to see what are natural kinds of fingers. A small variation of this is a 2-finger pin and then a 3rd finger to do the crossing action. We also looked at a single finger pin after a dragging action. This is similar to that drawing example I just showed. So I do a standard dragging action, I stop, and then I do my crossing action like that. And we had the same variation doing after the drag with 2 fingers. So these are our 4 different tasks that we evaluated, and you can see how they generalize to some of those demos that I showed earlier. So here are our high-level results. So imagine those 16 targets arrayed across the x-axis on the bottom. This shows an effect of time. There's a bit of an effect, as you can see, around north-northwest. The variance increases, there's a little bit of a bump there. If I overlay on top our error rates, so the error rate, and this is showing between 0 and about 10%, it's under 5% in many of those targets, but there's a couple peaks where, again, around north-northwest, a little bit in south-southeast, where it jumps up in some of the techniques. The dashed line is a 5% rate, which is pretty acceptable. And even more revealing, perhaps, is just subjective preference. So we had all participants rank each of these different targets on a scale of 1 to 5. I've inverted the preference scale here so that best preference is lower, just to make a nice visual correlation between these different figures. And you can see, again, there's sort of a similar pattern, but amplified a little bit more with preference. So I could tell you about all sorts of statistical tests, but that's not really what's important. The important thing is to look at this overall pattern. You can see which kinds of targets are actually probably good targets to use, and which ones should be used more sparingly or maybe avoided altogether. I can unwrap that blue piece and show something that's a bit more intuitive. So here's some design implications for probably where you should apply, where you should lay these radial targets for the crossing target for 1-finger pins and 2-finger pins. These are for the without dragging. And then here's the slightly different angles if you're doing a 1-finger pin or a 2-finger pin after a drag. So, and the other thing I can do is I can tell you about looking at the motion kinematics. This sort of supports a sort of an obvious, I think, hypothesis that people tend to cross rightmost targets in a clockwise direction and then counterclockwise for leftmost targets. And this helps you because, remember, you can attach 2 different commands to each crossing target. So I can put the most commonly accessed command in either clockwise or counterclockwise direction, depending on the side. So I said the other thing that we gathered were all sorts of motion kinematics, looking at how people cross, how people pin, so how much do they move their pin finger, how quickly do they cross, this kind of thing. We used all of these, this kinematic data, calculated some statistics on it, and built a pretty simple but surprisingly robust heuristic-based recognizer. So no fancy machine learning here. We just have a bunch of if statements and some empirically derived thresholds. And it's good enough in our evaluation that it actually distinguishes between rotate, scale, transform, and scaling, and so forth. So there's lots of details in the paper about that. So once now we have a sense for where to put the targets, and we have a sense for how to design the recognizer. Well, we designed a simple context menu of this pin and cross, and we wanted to compare it against some competing techniques. And we chose sort of equivalent menu techniques, each of them be able to support at least 8 menu items. So I'll explain what those 3 techniques are. So of course we had pin and cross. So here are where the 8 targets were located. Notice that some targets have clockwise and counterclockwise direction. And the task worked like this. can pin a central target and then cross whatever the required target was. And we can measure time and error and so on. We also compare it against a marking menu. In this task, we're assuming that target could be dragged, so we have to incorporate that long press, which is 1/3 of a second, to disambiguate between dragging the target or actually activating the marking menu. And in the experiment, they could actually drag the target by accident, although they didn't do this too often, but there is a time penalty there. And thirdly, we compared against a partial pi menu, which is an adaptation of Van de Vick et al.'s work. They did something for a tabletop. Here we had the same rule that it had to be 1/3 of a second long press to distinguish between two nearby taps. So we compared these 3 techniques, and pin and cross is faster, significantly faster than the other techniques. We can look a bit more closely about where that time is spent. So the performing time is the time to actually do the crossing action in the case of pin and cross. For the marking menu, it's the time to make the stroke. And the pi menu, it's the time to press and release the pi slice that you want to select. This sort of awkwardly named waiting period, the green period, is different for each of these cases. For pin and cross, it's the time from the moment that you first select the pin target until you begin making the crossing action. For the marking menu, it's the time to select the target, but also there's this 1/3 of a second timeout hidden in there. And the pi menu has also this 1/3 of a second timeout hidden in there, and then the time to just position the other finger on top of the pi target. So an interesting exercise is I could remove that 1/3 of a second, because we're kind of kneecapping those 2 techniques a little bit just to support the dragging action. And if we take that out, we still get, there's now no significant difference between the different techniques, but there's, so they're basically comparable in some ways. But of course, pin and cross has this extra benefit that it still allows this quick disambiguation between dragging and nearby command selection. So I'm going to show you some expanded demos now that you saw a brief glimpse earlier on in the talk. And I'll talk about these 4 different types of scenarios, everything in a sort of photo editing and annotation app or photo management app. So first, here's the context menu again, so showing how you can rotate thumbnails. Rotate has this really nice natural affordance because of the direction built in. You can cut thumbnails out or cut photos out. You can also go into a selection mode and then use conventional tap and then use pin and cross to deselect items or even exit the pin and cross or exit the selection mode entirely. Here's showing the edge selection. So I can rotate this object on the edge. And here's combining pin and cross with the marking menu as well. So they're not only sort of comparable in time, but they can combine quite easily. So selecting one of the certain crossing actions goes into a marking menu, in this case to share to different Evernote and Facebook and so forth. So here's scrolling again. So we had 2-finger scrolling to disambiguate between dragging targets and scrolling. I can use different nearby fingers to either page up or page down, skip to the bottom, skip to the top. You can see that pin and cross becomes a gesture in its own right. And here's the rotate, scale, and transform, just to see this one again. So this is the most challenging part for the recognition heuristics, to disambiguate between this. And there's snapping on and off. The one case where the heuristic sometimes fails is if you do a very particular kind of rotation where you anchor one finger very securely and then do a very quick rotation. But in practice, this doesn't happen very often. And finally, here's an expanded demo of the direct manipulation and drawing. So here I can begin a drawing motion without lifting my finger, change the drawing mode to something else. I can also change the line qualities to make them, thicker. There's another example where I'm going to switch back to the drawing rectangles and then change the color and the line style as well. So that's all done without leaving. So we have got this nice contextual command, and we've got this quality that we can, in the midst of doing these direct manipulations, we can actually alter what that direct manipulation is doing. So just to conclude, our contribution is that pin and cross is a new touch overloading input space that combines these static touches, which you call pins, with nearby crossing selection. There's still a lot of an interesting space here in using two hands, maybe even distant crossing actions, maybe different kinds of crossing targets, and we're continuing to explore this. So thank you very much, and I'm happy to take your questions.
Before people start slipping out, I just wanted to remind everyone to please vote for best talk. Obviously, these take a tremendous amount of time to put together, so please let's reward good presenters. And we have a first question.
Hi Dan, nice work. Michel Baudouin-Lafont, Université Paris-Sud, Paris-Saclay. From the videos, it looked like the users anticipate which command they're going to cross and adjust the finger they're using. So that works well for an expert user, but for a novice user, you may end up with if you want to cross undo here, it's going to be much harder if you started with your index finger. So can you change your mind?
Right, yeah, so number one, so it's an excellent observation, and there is a novice versus expert. So the nice thing about this is that it's very easy to back out, right? So I can pin something, realize that I pinned it with the wrong finger, and lift it up. And because of that, I've kind of got, by the time I figure that out, I've got sort of a long press built in. As long as that's not overloaded to something else, which in this case we don't need to anymore, I can just switch my finger and do it again. There's actually turns out to be, I mean, it's somewhat anecdotal from the experiment because we didn't enforce different kind of fingering, but people do adopt these kind of like gesture-like actions. Like they actually start to remember, and we named, you can see when in the experiment, if you knew the numbers of the target, you started to know that like 4 and 5 were on the left, so people actually would change their finger to do that. Now it's, you know, sort of an easy observation, but it becomes this sort of gestural action. So yeah, there's some challenge there, but I think it's as long as it's easy to get out of trouble, then I think we're okay. Yeah.
And you think of trying to identify the finger through the shape of the contact, the thumb would be quite different from the other fingers? And
to actually change the action based on what finger is used, or, sorry? What?
Well, I don't know, maybe well, if you change the layout, it's going to be confusing, I guess.
Right.
But,
yeah, no, we could. I mean, it's compatible, it could be compatible with something like finger identification. So if we knew actually what finger they're pinning, we could actually change the menu based on that too, which maybe could be the future in some ways. So, and we did, I mean, I didn't talk about it in the, we sort of, from looking at the data, we know what fingers they typically use. You know, for one finger pin, they do use index and middle. For two finger pin, they use these fingers, and then they always use one of the adjacent fingers on either side. So there's a little, they're not using all 5 at this point, but maybe we could enforce that. It would be interesting.
Thank you.
Dong Yun from Cornell. I have 2 questions. First one is, have you ever seen anybody who feel more comfortable with a non-preferred hand with this, rather than using preferred?
Would people be more comfortable with the non-preferred hand?
Yeah, for this.
I don't know. I mean, yeah, we only tested preferred hand action, and all the participants were right-handed. It's just a control for that. But it's an interesting observation that if you had a multi-touch system, I could have my non-preferred hand doing some actions to the side. Yeah.
Yeah, I feel like based on the Gibson's bimanual hand model, maybe pinning is making a reference, so it might be useful to think about that approach as well.
Right, and then do some other kind of continuous, once I've got it pinned and ready to go, do something.
Oh, not bimanual, only with this hand, pinning and the other.
Okay.
Yeah.
Right.
The other question is, did you think about the hand holding pen doing this?
So the hand holding a hand? Sorry?
Holding a pen.
Oh, holding a pen, yes. Yeah. Well, clearly it would be pretty difficult to hold a pen and do this kind of action. It would be interesting, I mean, now that you mention it, I've done work in the past with sort of pen-like devices and about palming them and then doing some touch input. And sort of just thinking right now from you saying that, I think I could palm a pen and still do some sort of limited pin and cross action with the 2 fingers I have left. Thanks. More future work, yeah. So thanks.